let f of x be x over x minus 1 and g of x be 1 over x. What is f composed with g of x? Remember, that means f of g of x, which is f of, now replace g of x with 1 over x, so 1 over x. That's what I'm doing in red. Which means that f is now 1, sorry, wrong color. It's going to be 1 over x over 1 over x minus 1. Substituting 1 over x for each time we saw x in the original of f. And then a bit of simplification here. I'm going to simplify the denominator first. 1 over x minus 1 is going to be 1 minus x over x. And remember that this means, really this means this divided by this. So it's 1 over x divided by this, which is the same as times x over 1 minus x. So we just get left with 1 over 1 minus x as our final answer. A few ways to think about this sort of simplification process here. You can either think of it as this way, it's a big division, so 1 over x divided by 1 minus x over x, which becomes times by x over 1 minus x times by the reciprocal. Or because the denominator is the same, we've got 1x over 1 minus x, x's. And so those x's are going to cancel, we just get 1 over 1 minus x. Two different approaches there. What about if we go the other way, g composed with f of x? That means we're doing g of f of x. That is, g of f of x is x over x minus 1. G is 1 over x, so it's 1 over x minus 1. So that is, it is the reciprocal of this, which is just x minus 1 over x. Two different answers, as we expect. The composite functions do not give the same result. Now we're thinking, what is the domain and range of f composed with g of x? So that's g first. What goes into g? What comes out of g? And then what goes into f? And what will come out of that? So what can go into g first of all? Well, g is 1 over x, so it can be anything except for 0. What can come out of that? Again, anything except for 0. And what can we input into f? Into f we can input anything except for 1. Because if we input 1, we'd get a denominator of 0, so we can't input 1. If we can't input 1, that means we can't get 1 out, which means we also can't input 1 here, because if we input 1, we would get 1 out, and that would not work there. And what would be our result then? Well, we can get anything except for when x is 0 or x is 1. When x is 0, this would give us 0, so we can't get out 0. And when x is 1, we would be dividing by 0, so that would also give us that's going to give us the vertical asymptote, so it's not going to affect what we get out of it in the end. Okay. So we can't get x equals 0 out of this, we can get anything else. So our domain is all values of x as long as x is not equal to 0 and x is not equal to 1. And our range is all values of y so long as y is not equal to 0.